0 to 10. Okay, that's it. Look at here, we have connectivity without any problem. Why? Because our IP addressing, okay, are correct, our subnet mask are correct, our default gateway are correct. If you, for example, configure with mistake some of them, one of them, you will experience, for example, some problems in connectivity. For example, let me to configure the PC1, okay, with one incorrect IP address. For example, here, this is the network interface card of the PC1. I am going to convert the subnet mask to 255.255.255, then 240, okay, means /28, and then okay, and then okay, and then for example, we can use the close, okay. And after that, let me to try to send traffic first to the PC2. Look at here, ping, then 10.1.1, for example, 20. Okay, as you can see, we have problem to sending traffic to the PC2, and now we have connectivity. Why? You know that first the traffic went to the router 1, and then the router sent traffic to PC2, and this means that we are using suboptimal routing, and this is not good. Okay, first we send traffic to router 1 because the PC1 now thinks that the destination is residing outside of its networks. I have explained it. Okay, if you want, you can verify the trace route here in this, for example, PC1. I'm going to use the trace command, trace RT, then for example 10.1.1.20. okay, look at here. After some, we can use for example trace route for finding the path. The first IP is the IP of the router, and then the PC2, and this is not good. We are using suboptimal routing, and maybe in some cases we experience the disconnectivity between the PC1 and PC2. The reason of this problem is the incorrect subnet mask. You can use ipconfig to find the problem. Okay, after that you can correct it. Let me to correct this problem, okay, in the computer network interface card. And after that, when you are configuring the correct subnet mask, again you will have connectivity, but with optimal routing. Look at here, now we have connectivity, and also this is the result of the trace route or trace RT, or for example 10.1.1.20. okay, let me to show you again trace RT 10.1.1.20. okay, look at here. Now we can send directly traffic to the 10.1.1.20, and this is the efficient behavior. Because of that, now we can understand that we should configure the correct IP address, correct subnet mask, and default gateway. Let me to remove the default gateway from the PC1. This is the PC1, and I'm going to remove the default gateway address from the PC1. okay, because I'm going to show you that we need default gateway for communicating with outside of this network. Here, this is the CMD again. ipconfig can show us that we don't have default gateway, and then for example ping 192.1.0.1. About the connectivity inside of the network, we don't have problem. Look at here, ping 10.1.1.20. look at here, we don't have any problem. Why? Because we don't use the default gateway. But about the outside connectivity, we will have problem. Ping 192.0.2.10. look at here, we don't have connectivity. Why? Because we don't have default gateway. okay, and you need to verify this problem with the ipconfig command. okay, look at here, let me to add again the default gateway IP address. As you can see, all of these features, IP address, default gateway, can be important for connectivity, and you should configure them correctly. One of the other features that we should carefully design it is the IP address of the default gateway. The IP address of default gateway should reside on the, for example, network of the PC. Okay, let me to give you one example. Here, assume that we are configuring this IP address for the PC1, 10.1.1, for example, 70/26. okay, this is the IP address of the PC1, and here, as you can see, we are using /26 means 255.255.255.192 as the subnet mask. okay, the first thing that we should do is the determining the network addresses of the, for example, this IP address. You know that in CCNA we have learned about the interesting octet and how we can find the network address of one IP address. Let me to review this feature. First, we need to find the interesting octet. What is the interesting octet? You know that, for example, here, if you have one subnet mask 255.255.255, for example 192, the interesting octet is the octet force. Actually, we can say it's the last octet that is greater than 0. Here, as you can see, the last octet that is greater than 0 is 192. Or for example, in this example, 255.255, then for example 192.0, the last octet that is greater than 0 is the octet 3. Because of that, we can say the octet 3 is the interesting octet. Okay, but what is the usage of the interesting octet? You can use the interesting octet to find the magic number. Okay, this is a topic about the CCNA course. I'm going to review it for you. For example, here we are using the 255.255.255.192 as the subnet mask, and the interesting octet is the octet 4. Okay, because of that, we can subtract the value of the octet 4 from the 256.192. Okay, and the value equal to the 64. Because of that, we can find easily the network addresses of this IP address 10.1.170. For example, the first IP address, the first range is 10.1.1.0/26. The second is 10.1.1.1, for example 64/26 again, and after that 10.1.1.128/26, and after that 10.1.1, for example 192/26. That's it. Okay, and here, as you can see, this IP address 70 is residing in this range, because in the 10.1.1.64/26, this is the network number, and the for example broadcast address of this network is 10.1.1.127/26, and we can say that this IP address 10.1.1.17, okay, /26 is residing in this thing. Because of that, now the network address is 10.1.1.64/26. Okay, we can compare this IP address with the default gateway. Look at here, default gateway is residing in another network, in the first network. Okay, because of that, actually this default gateway cannot be used for sending traffic to the outside of the network. The reason is that the IP address of the PC1 is not residing in the same network with the IP address of the router 1. Again, we have problem. Okay, I will show you, but for now, let me to say that you should carefully design the IP address, subnet mask, and also default gateway. The first requirement is that all of the systems in one network should use the same network ID, and also all of for example, systems in one network should use different host ID. After that, the default gateway should be accessible with the PC. Okay, here, as you can see, 10.1.1.17, okay, cannot send traffic to 10.1.1.1. Okay, why? Because the default gateway address is residing in another network. Also, if you want, you can compare the two address. For example, network ID, if you want, you can use it. For example, let me to show you about the 10.1.170/26. We can use the binary, okay, the binary conversion. Here the binary is quad 0, 10, 10, 10, and then again 0, 0, 0, 0, quad 0, then again quad 0, then 1. Okay, quad 0, 0, 0, 0, 1. That's it. And then quad 0, 0, 0, 0, 1, and finally 0, 1, okay, 0, again 0, 1, 1, 0. Okay, look at here, this is equal to the 1764 plus 6. And then here we need to compare it with 10.1.1.1, okay, / for example 26, and let me to convert it to the binary. Again, about the first octet we have the same value, about the second octet we have the same value, and about the third octet also we have the same value, but here as you can see we have 0 0, then again 0 0 0 0 and 1. Okay, as you can see the first 26 bits. Okay, now for example